3I/Atlas, the Watchers on Mars. While NASA's deep space networks flicker in and out of contact, and Earth's telescopes are forced into silence by the glare of the sun, something extraordinary unfolds on the far side of the solar system. A third confirmed interstellar visitor, 3I/Atlas, rushes past Mars at a blistering 30 million kilometers away. It burns like an emerald shard against the void, trailing an electric green ion tail that defies every comet model ever written. And as this alien traveler reaches its closest pass, Earth goes blind. The irony cuts deep. For the first time in history, the most advanced scientific nation on the planet can't see the one thing it most wants to. Our own sun turns into a curtain, a blinding wall of plasma between us and the interstellar unknown. From Earth's view, the elongation angle, the slim arc of sky separating the sun from 3I/Atlas, collapses below 10 degrees. That's a hard limit for every major observatory on the planet. To look there is to risk burning optics, frying sensors. So, as of October 3, 2025, Earth is officially cut off. But Mars isn't. Offset by more than 40 degrees in its orbit, the red planet holds the only clear vantage point. While Earth's skies are washed in sunlight, Mars becomes the solar system's only working watchtower. Europe's Mars Express, the Trace Gas Orbiter, China's Tianwen-1, and the UAE's Hope Probe, all of them, machines built to study the Martian atmosphere and soil, now find themselves in a race against time to observe something no human has ever seen before. On Mars Express, engineers scramble to reprogram cameras and spectrometers, tilting them away from the planet to track a moving speck of light. The Omega spectrometer switches from surface mapping to hunting volatile gases in the comet's coma. The Trace Gas Orbiter splits the light of 3I/Atlas into thousands of wavelengths, searching for exotic molecules, rare isotopes, maybe even compounds that shouldn't exist. The Hope Orbiter shifts from global weather monitoring to emergency wide-field imaging. Its ultraviolet spectrometer, meant for thin air and dust storms, is suddenly staring into deep space, recording emissions that pulse and flicker like coded signals. And then there's Tianwen-1, its cameras designed for Martian valleys, now catching long-exposure frames of a ghost green blur crossing the stars. For a few fleeting orbits, these machines become humanity's eyes. Each downlink window is critical. Every packet of telemetry, every grainy snapshot might contain the key to understanding what 3I/Atlas really is, and where it came from. Mission planners abandon protocols. Safety margins shrink. Teams on Earth work through solar interference, patchy communications, and overlapping priorities. The data flow is unstable, fragmented, but the glimpses that make it through are electrifying. Unusual spectra. Surges of brightness inconsistent with normal comet outgassing. A dense, structured magnetic field signature that shouldn't exist for an object this size. Something about 3I/Atlas doesn't behave like a natural comet. The geometry will soon shift again. Within weeks, Mars will lose its line of sight. The Sun will claim the object completely. And when it reemerges into dark space beyond Earth's orbit, it may already be too far, too faint, and too fast to ever be seen again. For now, the red planet holds the only message. And somewhere, in the flood of raw data streaming back through the noise, humanity's first clear look at an interstellar mystery waits to be decoded. The first packets of data arrive in fragments. Scrambled, incomplete, but unmistakable. From Mars orbit, ESA's Mars Express sends back a set of multispectral frames taken just hours before the comet began to fade into the solar haze. The images show a glowing nucleus wrapped in a shimmering emerald halo. But there's something wrong. The structure isn't random. At full resolution, the dust plume resolves into fine concentric ripples, like shock waves frozen in space. The symmetry is unnatural. The Trace Gas Orbiter confirms it. Spectral lines appear that don't correspond to any known molecular emission. Not water vapor, not carbon monoxide, not cyanide, the usual suspects of comet chemistry. These lines repeat in precise intervals, almost rhythmic, like modulation. Across the planet, in Abu Dhabi, the HOPE mission team stares at ultraviolet spectra they can't explain. Their instruments pick up brief, sharp flashes from the comet's coma, ultraviolet bursts spaced exactly every 11.6 seconds. Too regular to be random. At the same time, a deep space antenna on Earth catches faint carrier noise buried in solar interference. A whisper of radio static that rises and falls in sync with the UV pulses. The timing matches within milliseconds. For a few tense hours, no one knows what to think. The first instinct is instrument error. Crosstalk, sensor echo, software glitch. But multiple spacecraft, built by different nations and tuned to different frequencies, record the same event. Then comes the image. China's Tianwen-1 sends a long-exposure composite through a noisy downlink. When processed, it reveals a filament stretching thousands of kilometers behind the nucleus. But instead of diffusing outward like a normal dust tail, it bends, oscillating with geometric precision. Not random turbulence. Not solar wind. Pattern. Mission control rooms across continents fall silent. Something about 3I/Atlas moves with intent. In Houston, a NASA liaison writes in his nightly report, "The data is internally consistent but externally impossible." Over the following days, the Mars orbiters continue to record fluctuations. Each pulse seems to shift slightly in wavelength, as if the object is adjusting, recalibrating, reacting. Scientists hesitate to use the word signal. But among the teams analyzing the data, one term begins to circulate quietly in encrypted chat rooms and late-night briefings. Structured emission. No one dares to say what it means out loud. The comet is already fading, its brightness dropping fast as it swings behind the sun. Within a week, it will vanish from every lens and sensor in the solar system. But before it does, one final transmission from Mars Express comes through. A short visual scan at the edge of the comet's coma. The frame lasts just 0.8 seconds before the camera saturates. But in that instant, the green haze resolves into an array of angular forms. Too sharp to be dust. Too precise to be natural. Then the feed cuts. The file header timestamps it to October 5, 2025, 4:22 Universal Time Coordinated. After that moment, 3I/Atlas disappears behind the solar corona. And for the first time, humanity is left with a question no telescope can answer. Was it just a comet? Or something pretending to be one? 3I/Atlas, the return from the light. For 6 weeks, the solar wind carried silence. No images. No spectra. No signal. Just the memory of a green phantom that defied every rule of celestial mechanics. Then, on November 17, 2025, ground-based observatories in the southern hemisphere begin scanning the dawn skies, searching for the returning interstellar traveler. It should reappear faint, diffuse, fading fast as it escapes the inner system. But what they find is something else entirely. At first, it's just a blip in the data, an infrared flare picked up by the Atacama Pathfinder in Chile. A few hours later, the James Webb Space Telescope confirms it. The object is back in view, and it's brighter than ever. Not dimming. Intensifying. The light curve spikes unpredictably, cycling in short bursts, rapid, deliberate pulses that no comet should produce. The frequency is the same as the pattern recorded by Mars orbiters, 11.6 seconds. Astronomers scramble to recalibrate their instruments. Every known comet, every dust model, predicts fading as solar energy disperses the coma. But 3I/Atlas behaves like it's feeding on the light, amplifying instead of diminishing. Spectral data from Webb and ground telescopes in South Africa show impossible chemistry, narrow emission bands clustered around frequencies not seen in any natural plasma. The pattern repeats across multiple instruments, multiple continents. Meanwhile, NASA's Deep Space Network reports faint, coherent radio bursts riding on top of the background noise. The signal seems to lock onto the Earth-Moon system, maintaining a constant angular offset, as if the object is tracking something. By November 19th, the comet's coma has restructured. High-resolution composites from the Subaru telescope in Hawaii reveal an elongated shape, not spherical, but lattice-like, almost architectural. Within the glowing green halo, darker voids form in a hexagonal grid. Each frame shows micro-adjustments, as if the structure is reorienting itself. The media calls it a living comet. Online forums call it a probe. In official channels, it's renamed Object 3I/Atlas b. A cautious bureaucratic way to admit something has changed. Then, just as quickly as it returned, it begins to accelerate. Not from solar pressure, not from gravity assist. The acceleration vector is opposite the Sun, as if it's pushing away under its own power. Telemetry from multiple observatories confirms a consistent thrust pattern. By November 24th, it's already exceeding solar escape velocity. By the 25th, it's gone, a fading emerald spark slipping into deep interstellar darkness. What's left behind are fragments, microscopic dust particles collected by Earth's upper atmosphere probes days later. Their composition doesn't match any known interstellar material. The lattice of each grain contains ordered silicon-carbon microstructures, smaller than a virus, perfectly symmetrical. When magnified, the pattern repeats the same harmonic intervals as the spectral pulses recorded weeks earlier. An echo, encoded in matter. And somewhere beyond Neptune's orbit, 3I/Atlas continues to accelerate. Not tumbling. Not random. A straight, stable course into the void. As if it came here for something. And now, having found it, it's going home. 3I/Atlas, the message in the dust. December 2025. By now, the world has moved on. The news cycle calls it the Green Comet Mystery. 100 theories circulate online: alien probe, magnetic anomaly, plasma mirage. But in a few quiet laboratories, far from the headlines, something extraordinary is unfolding. The recovered dust samples, microscopic fragments swept up by high-altitude collectors over the Pacific, are unlike anything seen before. Under electron microscopes, each particle looks engineered. Not crystalline. Architected. At the nanoscale, the grains reveal intricate frameworks, repeating hexagonal lattices with internal channels measured in nanometers. Each channel is filled with alternating deposits of carbon and silicon compounds arranged in strict binary intervals. To the naked eye, it's just dust. To a spectrograph, it's information. At first, the team at the European Synchrotron in Grenoble assumes it's coincidence, natural symmetry. But after hours of scanning, a young data scientist runs the lattice pattern through an FFT algorithm, converting the spatial geometry into a frequency domain. The output stuns everyone in the room. The waveform is clean, ordered, repeating every 11.6 seconds. The same signature recorded by Mars orbiters, by Webb, and by every telescope that ever caught a glimpse of 3I/Atlas. Only now, the signal isn't light or radio. It's matter itself, carrying a harmonic code embedded in physical form. Weeks pass. Teams from Japan, Germany, and the US confirm the pattern. Each sample holds variations of the same design, like fragments of a much larger group. When digitally reconstructed, the lattices align into a three-dimensional structure resembling a geometric field, folded and recursive, as though it's describing space itself. NASA analysts call it a topological map in 6 dimensions. The media never hears that phrase. The data is classified before publication. In private, a handful of scientists continue decoding in silence. What they uncover next changes everything. Buried deep within the harmonic pattern are discrete anomalies, phase jumps that, when converted to audio, produce a sequence of tones. At first it sounds random, static noise. But when slowed down and aligned with pulse spacing, a rhythm emerges. Structured. Intentional. One of the researchers overlays the waveform on a logarithmic time scale. The pulses correspond exactly to prime numbers 2, 3, 5, 7, 11, 13, 17. And then stop. A universal signature. An intelligent fingerprint. Across 3 continents, encrypted messages circulate among the project leads. No one can explain how an interstellar object could carry such precision, or why it would choose to express it this way. And yet, the data is unambiguous. The final decoded layer, hidden within the harmonic noise, forms an interference pattern, a projection. When rendered in 3D, it resolves into a rotating lattice, a sphere within a sphere, intersected by lines converging toward a central void. At its center, a simple frequency coordinate, one that points to a region just outside the heliopause, beyond the reach of our spacecraft. It's not a random emission. It's a return address. By early January 2026, the official reports end. Funding is redirected. Public databases are wiped. But copies of the decoded data persist, quietly mirrored by a handful of scientists who can't let it go. They agree on one thing. 3I/Atlas wasn't just passing through. It was leaving something behind. 3I/Atlas, the echo beyond the sun. By February 2026, the world has forgotten the green comet. But in a handful of deep space monitoring stations, Canberra, Madrid, Goldstone, something begins to stir in the static. It starts as a faint modulation on the Deep Space Network's carrier noise, just above the cosmic background, repeating in 11.6-second intervals. The same rhythm. The same signature. At first, engineers think it's an artifact, cross-feed from a spacecraft telemetry band. But the signal doesn't match any mission profile. It isn't coming from the inner system. It's coming from outside. When triangulated across the 3 DSN stations, the signal's origin traces to a narrow region of interstellar space, right beyond the heliopause, roughly 87 astronomical units from the Sun. Exactly where the decoded coordinates from the 3I/Atlas dust lattice had pointed. The realization spreads quietly through mission control networks. Within 48 hours, the Voyager 2 team is ordered to retune the probe's instruments. Though the 47-year-old spacecraft is nearly blind and deaf, its plasma wave subsystem still functions. On March 1st, it detects a faint, structured fluctuation in the interstellar medium, identical in timing to the DSN signal. Something out there is transmitting, and it's responding to us. The next week, NASA's Jet Propulsion Laboratory, the European Space Agency, and JAXA coordinate an unsanctioned test, a low-power encoded ping sent along the same direction, a binary string repeating the 3I/Atlas harmonic sequence. A simple question, in the only language we share. Are you still there? For 2 days, nothing. Then, at 4:22 Universal Time Coordinated, the exact timestamp when Mars Express lost visual contact months earlier, the DSN logs a return. A burst, faint but coherent. Not noise. A mirror pulse. It repeats their message back, slowed by a precise factor of 2, as if acknowledging receipt. Every console operator freezes. No one speaks for almost a minute. Because in that silence, the implication is undeniable. Whatever 3I/Atlas was, it left something behind at the edge of interstellar space. And now, it knows we're listening. Over the following weeks, the signal begins to evolve. New modulations emerge, layered harmonics building on the original pattern, as though it's adapting, teaching itself how to speak. Radio astronomers describe it as linguistic drift. The waveform structure mirrors human transmission delays, frequency corrections, even Doppler compensation, like it's learning our mistakes. On March 14th, the first optical confirmation arrives. A faint, non-reflective object detected by the Subaru telescope in infrared, moving slowly against the galactic background, exactly along the predicted vector. Its albedo is near zero, its size indeterminate. But when analyzed, the emission shows the same spectral fingerprint as 3I/Atlas, emerald green ionization lines, perfectly stable. Whatever is out there, it isn't a comet. It isn't debris. It's active. For the first time, humanity faces the possibility that 3I/Atlas wasn't just a traveler, it was a messenger. And what waits beyond the sun might be the one that sent it. 3I/Atlas, The Threshold. May 2026. The message from beyond the sun has now repeated over 10,000 times. Every transmission identical in frequency, structure, and delay, except for one change. Each week, the signal grows slightly stronger. Closer. No known spacecraft could move that fast. No known process could produce that precision. And yet, the data is flawless. By early June, the Joint Mission Plan receives final approval under a name that never appears in public records. Project Helios Delta. A single unmanned probe, built in silence from redirected components of existing spacecraft. 1 part ESA, 1 part NASA, 1 part JAXA. The goal: to cross the heliopause and intercept the source of the repeating signal. Launch: August 2nd, 2026. Trajectory: direct escape via Jupiter Assist. Estimated arrival: 11 months. The probe, codenamed Argus, carries no crew and no return capability. Its sole directive is to transmit everything, continuously, redundantly, in multiple wavelengths, until its systems fail or its signal is lost. For months, Argus races outward. Past Mars. Past Jupiter. Past the orbits where sunlight fades into starlight. The further it travels, the clearer the signal becomes. No longer a pulse. Now a tone. A resonance that modulates with the probe's own transmissions, as if synchronizing to its heartbeat. In November, Argus passes $70 just inside the Helios ship. That's when the anomalies begin. Ground control notices subtle phase noise across all deep space channels. Then data echoes, Argus telemetry repeating itself seconds after transmission, but mirror inverted. At first, it seems like interference. Then, as operators overlay the two streams, they find perfect coherence. The returning data anticipates the next transmission by exactly 11.6 seconds. Argus is being answered before it speaks. At $85, instruments begin to fail one by one. First, the magnetometer freezes, constant maximum readings. Then the plasma analyzer returns negative densities, impossible values. Cameras show only static, a faint green flicker pulsing at the edge of every frame. The probe's internal clock begins to desynchronize, drifting forward in time by fractions of a second with every orbit calculation. Each correction increases the error. Telemetry timestamps lose meaning. It's as if the probe is approaching a region where time itself bends. On December 14th, Argus crosses the estimated boundary of the heliopause. For 23 minutes, everything stabilizes. Clear signal, steady transmission, full systems nominal. Then, without warning, all readings flatline. Every sensor reports zero. Only the carrier tone remains, pure, flawless, sustained. And through that tone, a modulation emerges. Slow, deliberate pattern. Binary. The same harmonic key embedded in the 3i/Atlas dust lattice. Translated, it forms a sequence that ground control can read only as a single, repeating phrase. Transmission received. After that, nothing. Argus vanishes. No telemetry. No echo. Just silence, stretching across 80 billion kilometers. For 3 days, every deep space antenna on Earth listens. On the 4th day, the silence breaks. Not from beyond the heliopause, but from inside the solar system. A new source appears near the orbit of Neptune. Same frequency. Same modulation. Same 11.6-second pulse. But this time, the signal isn't approaching. It's coming in. 3i/Atlas, the return. January 2027. For the first time since 3i/Atlas vanished beyond the Sun. The signal no longer drifts in deep space. It's moving inward, slow, deliberate, perfectly aligned with the ecliptic plane. Every 12 seconds, the same emerald pulse flickers across the radio spectrum, mirrored by a faint ultraviolet flash that even amateur telescopes can now detect near Neptune's orbit. Whatever it is, it's enormous. And it's slowing down. The data from the James Webb Space Telescope arrives first. The infrared imagery shows an object surrounded by a dense plasma halo, hotter than any comet tail, but geometrically confined. A perfect sphere of ionized gas, oscillating in concentric waves. Inside, a darker core reflects almost no light at all. When the spectral filters are aligned, the inner structure resolves for the first time. It isn't debris. It isn't ice. It's lattice. The same hexagonal geometry first found in the dust. Only now, spanning kilometers across, shimmering with organized precision. Then the pattern shifts. At exactly 4:22 Universal Time Coordinated, the entire field pulses once, bright enough to momentarily saturate Webb's detectors. When the instruments recover, the halo has changed shape. It's no longer spherical. It's folding. Segments interlocking, lines collapsing inward like a flower closing in reverse. And in the center, for a fraction of a second, a gap appears, a hollow void surrounded by structured light. Through that void, a beam of narrow-band radio cuts directly toward Earth. No dispersion. No delay. A straight line. Deep Space Network receivers pick it up across all stations simultaneously: Canberra, Madrid, Goldstone. The signal bypasses atmospheric distortion, frequency drift, even time delay. The waveform is impossible. When decoded, it's not binary anymore. It's image data. The reconstruction takes hours. First noise, then gradients, then structure. In silence, mission directors and scientists across the globe watch the final frame resolve. In the corner of the image, a small marker glows, the same coordinate embedded in the 3i/Atlas dust. 87 Australian dollars. And beneath it, one last sequence of pulses. 11, 6, 11, 6. Slowing, fading, then stopping. The signal ends. For weeks, telescopes scan the region near Neptune. No object. No glow. Only residual radiation, dispersing outward. As if the structure had folded itself back into space. On Earth, the dust samples remain locked in cryogenic storage. The repeating harmonic pattern within them still hums faintly when exposed to infrared light, a silent rhythm, like memory. And though official reports declare the phenomenon unconfirmed, every instrument that ever recorded 3I/Atlas still carries its spectral scar. A faint trace at 11.6 seconds. Some call it an artifact. Others call it a message still waiting to be answered. But those who were there, who watched the green light vanish one final time, agree on one thing. 3I/Atlas was never a comet. It was a question. And now, somewhere in the dark between the stars, something is waiting for our answer.